All right, so last time we talked about how elements that did not have a full outer shell were looking to fill their outer shell with other elements. And when they do that, they form a chemical bond, which is a force that links atoms together. All right, when we take two or more atoms and we put them together, we form a molecule. Okay. So here are all of the types of chemical bonds. The top three are the ones we're going to concentrate on. Okay, so an ionic attraction is when somebody is going to donate an electron to someone else, which means the person who donates the element that donates the electron will be positive, the one that accepts the negative electron will be negative, and then they are going to have an interaction or a bond because of that. So the other one that we're going to talk about is a covalent bond. So a covalent bond is when they share electrons. So for O2, this is two oxygens. They each need to fill their outer layer. So the way they do that is they actually form two bonds where they're going to share two electrons. And when they share the electrons, then each one of their outer shells are full. Okay, so the atoms get stability by having full outer shells. Okay, so each atom is going to contribute one to the sharing, and in this case, two to the sharing. All right, whether a molecule is polar or nonpolar depends on the type of molecule and shape. So water and carbon dioxide have polar covalent bonds. What does that mean? That means that they're sharing the electrons unequally. So one molecule is pulling the electrons toward them, making them just slightly negative, and the other molecule has the electrons further away, and that makes them more positive. The partial charges produce polar bonds or regions of polar bonds, and that is going to be what we're going to really talk about, which is the polarity of water and the different characteristics that polarity of water give. So if you look here, you're going to see that the oxygen is slightly negative. That's what this weird little thing means, slightly negative, and that each hydrogen is slightly positive. So this oxygen is going to be attracted to other things that are positive, including the hydrogens of other water molecules, and the hydrogens are slightly positive will be attracted to things that are slightly negative. So the interaction between the negative end of one and the positive end of another molecule is going to form hydrogen bonds. So we have covalent bonds. We have covalent bonds here that we were talking about. And so let's talk about these hydrogen bonds. Basically, the negative oxygen and the positive hydrogen are going to bond. Now, this bond's going to be pretty weak because the charges are weak, right? So because they are technically full on their outer shell, they're not desperate to hook up with another molecule, but because they have that slight charge, they are bonding with the other molecule, but that is still relatively weak. Because of the hydrogen bonds, it makes ice less dense than water. So when water solidifies, it actually forms this sort of lattice structure, which makes it less dense so that it can float. So that's a characteristic of water because of its polarity. Hydrogen bonds also connect two strands of DNA together to create a double helix. Oil and water don't mix because oil is nonpolar. In other words, it does not have any attraction to the water. So oil and water cannot mix. So another type of bonding is ionic bonding. And ionic bonding, basically one element has an extra electron on their outer shell and then donates it to the chlorine. Okay, so then that leaves the sodium, in this case, a little more positive for having given up that electron, and the chlorine a little negative from having gained that electron. Okay, because of this, we can then, this is just a graphic demonstration of that. So you can see that this ionic attraction, because now having given up that electron, that sodium is positive, and having gained that electron, that chloride is negative, and that actually bonds them together. And sodium chloride is salt, like table salt. Now, because ionic attractions are relatively weak, they're easy to dissolve in water. So we can take the water, and because of the polarity of the water, so the red is the oxygen and the plus, or the gray, is the hydrogen. Because of the polarity of water, that slightly negative end of the oxygen is going to be attracted to the positivity of the sodium. If you look over here, then the positive hydrogen is going to be attracted to the slightly negative chlorine. Now, because of that, we call water a universal solvent, because most things are either polar, or they're polar covalent, or they are ionic, and those, either one of those, because of the polarity of water, can be broken up. The only thing that water doesn't mix with is things that are non-polar, like oils. Water also has surface tension. So water molecules at the surface are bonded together because of that polarity, and it makes the water difficult to puncture. So if you've ever seen like a water strider or a spider literally walk on water, it's because of the hydrogen bonding of the water at the top. Okay. Hydrogen bonding between liquid molecules and solid surfaces is called adhesion. So basically, if you have like a straw, you're drinking out of a straw, the water molecules are actually going to attach to the side of the straw. So once you drink your liquid from a straw, when you let the water go back down, you'll see on the sides, there'll still be some droplets, okay? And that's because of adhesion. Now, water molecules also like to stick to themselves, and that is called cohesion. So when you take adhesion, okay, adhesion and cohesion together actually create surface tension. And adhesion, or the ability of the water to sort of attach to the legs of this water strider, and the cohesive properties, which are the water likes to stick to itself, making it a little stronger, allows this guy to sort of scurry on in water. Any polar molecule that can interact with any other polar molecule through hydrogen bonds. If it is a polar molecule or breaks up in water, we call it hydrophilic, which is hydro means water, philic means love, or hydrophobic. Hydro means water, phobic means hating. Okay, so like oil would be hydrophobic, salt would be hydrophilic. Now, when you dissolve things in water, you might get some release of hydrogen ions. So acids are substances that provide hydrogen ions and lower the pH. And bases provide hydroxide ions and raise the pH. The stronger the acid, the more hydrogen it donates. Okay? So like our gastric acid, that's your stomach acid down here, it's incredibly acidic. So that's like a 1. But but if you look here, milk of magnesia, which is like a supplement to lower your stomach acid, is a 10. So when you add the 10 to the 1, it brings it out to what we would call neutral, which is a 7. We talk a little bit about buffers, which absorb hydrogen or hydroxide ions to keep the body in balance. And that's really important. We use a lot of buffers in our system so that our blood or any of our bodily fluids do not become too acidic or too basic, because it's very toxic.